Hello and welcome back. This is lesson 2 of year 11 physics, unit on distance, speed and acceleration. Very quick recap. Lesson 1, we learnt how to calculate speed and the difference between speed and velocity. Remember, we use that equation highlighted, and in today's lesson, the equation we're going to be using, I'll highlight it in yellow again, is acceleration or deceleration. We learn the difference between those two during this lesson, is the change in velocity over time. And again, we'll be using these symbols here instead. Underneath you'll see another equation for acceleration, but that will be in lesson 3, where we'll be looking at distance time and velocity time graphs. Okay, so let's zoom past lesson 1. Remember, you did this last lesson. And we're on to lesson 2. Okay. Let's go over the learning objectives. What we learned in lesson 1 has been highlighted in yellow. What we're going to learn in lesson 2, we're now going to highlight in green. So we're going to learn about acceleration, and we're going to be using this equation. So 2 parts to it. What is acceleration and how do we calculate acceleration? Those are the learning objectives of lesson 2. Okay, so there's a very simple definition there of what acceleration is: the rate at which speed changes. Now, wherever you see the word rate, it's to do with time, how quickly something happens. Underneath that, it asks, when objects move faster, they accelerate. Look at the spelling of accelerate, 2 C's. But when you spell decelerate, the opposite, when objects slow down, there's 1 C. Just watch out for that. So, where something is speeding up, it's accelerating. When something's slowing down, it's decelerating. Here's the equation. Don't get put off if you sometimes see speed instead of velocity. I showed you at the front of this booklet, and it'll be the front of your exams, that it'll actually state acceleration is changing velocity over time. And because speed or velocity is measured in meters per second and time is measured in seconds, what we say is the unit for acceleration is meters per second squared. So write that underneath here. Okay, there's the background. That's what you need to know. And you notice here, look, we're using the term velocity. If you can't remember the difference between the two, just go back to lesson 1 for a recap. But don't worry too much about the difference for now. Question 1. Again, what I'm going to do, I'm going to answer question 1, scaffold slightly question 2, and let you answer question 3. And then the last activity of the lesson is page 11. So I think I've written it over next to the learning objectives. The pages we're doing today are from pages 9 to 11. Okay, let's get started. Let's get calculating. Farmer Palmer's tractor starts from rest and accelerates to 8 meters per second after 20 seconds. So just as I showed you in lesson 1, remember the 4 steps: equation, number, answer, units to get the full marks, E0. The equation for acceleration is change in velocity. Wherever you see a little triangle like that, it means the change in something. Change in velocity divided by or over time. That's the equation, that's your E. The change in velocity. Now, this could catch people out. You've got to pick up on certain terms or phrases that are used. And wherever you see the term rest, from rest, that means it's stationary, is another word that can be used. Right, so I'll write that down. That's another word that can be used. Again, look at the spelling. A-R-Y, not E-R-Y, E-R-Y, paper clips, pencils, paper, and so on. Stationary means standing still from rest, or 0 meters per second. 0 meters per second. Therefore, it's going from 0 to 8 meters per second. Now we can show that the change is 8 take away 0. That's the change in velocity. And it's a positive change because it's going from 0 to 8. The time taken here is 20 seconds. And you write that underneath. So I just need my calculator now to work that out. Should be able to work. 8 over 20, the same as 4. It's 4 over 10. So that's 0.4. But let's get in the good habit so we don't make a mistake. Could have opened this earlier really, couldn't I? Let's get my calculator in the screen so we can see what's happening. So I want to divide 8 by 20, as I said, the same as 4 over 10. 8 divided by 20. 4 over 10, which is 0.4. Just going to move the calculator down. 0.4. And of course, remember the correct units. Quick recap then. Equation, number, answer, units. That's how you get your full marks. So you get a mark. Equation, number, answer, units. Okay, let's look at question 2. Millie's on a scooter and takes 5 seconds to speed up. So it's going to be an acceleration, speed up from 4 to 13. The time taken is 5 seconds. Calculate the acceleration. I'm not going to do all of this for you, but what I will say is remember that it's going to be a positive acceleration. So what's the change in velocity from 4 to 13? I'll just finish off that equation. Scaffold it for you slightly. Time. So that 4 to 13, you work that out and you put that number there. I'm not going to say any more. Question 3. Car driver sees a speed camera, changes velocity from 22 to 10. It's a deceleration, therefore you should have a negative answer. Okay. As I did in lesson 1, I will just asterisk the work that I'd like you to do. So you need to finish that one. You need to start and complete question 3. And the final activity for lesson 2 is this. I'll read this out. The performance of very fast cars is important. Manufacturers spend a great deal of time and money testing the performance so that the numbers can be used to advertise and sell cars. The standard way of testing acceleration is to measure the time the car takes to get from rest, notice that word rest again, to 100 kilometers per hour. In the UK, we sometimes use the term 0 to 60. You remember 0 to 60, but there we're talking about miles per hour, mph. The higher the performance of the car, the shorter the time that it takes. Table 10.3 shows some data, so that's this underneath, from the world's fastest production cars, and for comparison, a standard Ford Focus 1.8. Okay, so let's just have a look. It's in order actually of the car with the highest acceleration. The Bugatti takes 2.4 seconds only to get from 0 to 100 kilometers per hour, or 0 to 60 miles per hour. And what it's asking you to do is to then create a table. Here's one I've done earlier. I've made a start on that table and 3 columns. I've highlighted in green what it's asking you to do. First column, type of car. Second column, time to reach 100 kilometers per hour. And third column, the acceleration. I'll do it for the first 2 cars and then you can complete the table yourselves. Bugatti, we look up, takes 2.4 seconds. Notice I've put at the top here, time to reach 100 kilometers per hour, but it's a 27.8 meters per second. That's more important because we don't work in kilometers or hours, we work in meters and seconds. I'm going to do my workings out to the side. You might want to do yours on the side of the page, but I'll just do mine over here. So change in velocity divided by time. I'll get my ruler. So we're going from 0 to 27.8. That's the change in velocity. The time taken, of course, is 2.4 seconds. Calculator. Let's move that to the side. 27.8. That's the change in velocity. It's a positive number. They're all going to be positive numbers in the table, divided by 2.4. The answer there, look, whoop, just flashed off, is 11.58. I'll round that up to 1 decimal place. 11.6, because it's 5.8, you round it up. And don't forget the units. 11.6. I don't need to write the units in the table because it's in the column. It's in the header row, I should say. At the units are there. I'll do one more. So all I'm doing here, I'm using the same equation. Obviously have the same units, and the time's going to be the same. The only difference is going to be, sorry, my mistake. The difference is going to be the time, not the velocity. So that change of velocity is going to be the same for each car. What's going to be different is the time. So if I look at the next one, the the aerial atom V8 is 2.5 seconds. I'll just write that in the table. I'll put that in my equation, substitute the numbers. Enter into the calculator. (11.12) rounded to one decimal place, 11.1. All the ones, 11.1. Okay. And that's it. That's it for today's lesson. Please make sure that you assess yourself on what you've learned during this lesson by doing the quiz, which will be underneath this video on the Moodle Study Zone. And also there'll be a video, a free science lesson, one of Sean's videos showing you again how to calculate acceleration if you need more guidance. I'm sure you'll do well if you just follow these steps. Please just rewind, pause as you need to, so that you understand the work fully. Okay, bye.